In the last lectures, we saw how to shift in time the signal and how to scale the signal in time. Now we'll see a quick summary of these operations and then some more examples and some extensive tutorial kind of workout on some examples. Okay, so the next two slides are going to contain a summary of the entire time shift and scale operations. So if you can understand what's going on in these next two slides, it gives a full overview of these two operations. Okay, so let's say that you have been given a signal x of t, okay, which looks like this, and the first thing that you have to do in order to time shift it or time scale it is to note down these critical time points. What are we calling it as? Critical time points are essentially nothing but the time instances where the signal changes its shape. So for this particular example, as you can see here, the signal becomes non-zero at t0 and then it changes its trend at t1 and t2, and then once again it becomes 0 at t3. So these are the critical points. Okay. Now whenever you shift the signal in time or scale it, essentially these points are the ones that are going to change. So that is why it is important to note down these points and then see what happens to them. The first operation that we saw was shift. So if you're going to shift the signal by some amount b, and if that b is negative, what happens? The signal moves to the right by the b amount, right? So this is what we saw earlier. So if b, the shift amount is negative, move to the right. If b, the shift amount is positive, then you move to the left. So effectively what happens is the signal shape remains as such, but the origin alone moves either left or right. So shifting is essentially nothing but changing the origin. So moving the origin from 0 to either b or minus b. Okay. If you shift in time by minus b, then the origin moves to b. If you shift in time by plus b, the origin moves to minus b. Okay. That's the shift operation. Now, there is also the other operation that we saw, which was the scale operation. So let's say you are going to scale the signal by a. Now, if this a is greater than 1, if the magnitude of a is greater than 1, what are you going to do? You are going to squish the signal. Basically, you just compress it about the origin. So you leave the origin, this y-axis as such, and about the origin, you just squish or compress the signal from either side. Just compress from either sides. Then what you get is this time scaled version of the signal when the magnitude a is greater than 1. If magnitude of a is less than 1, then what do? You just pull apart. Whatever is there in the left moves even to the left, whatever is on the right moves even to the right. So this is just stretching. So you stretch, pull from either side the signal, again about the origin. So if a is negative, then you do the same operations depending upon the magnitude, but before doing those, you just flip. Whatever is on the right side moves to the left, whatever is on the left moves to the right. Once you flip it, then if the magnitude is greater than 1, once again squish it. If the magnitude is less than 1, once again stretch it. So these are the shift and stretch operations. Now what if you want to do both simultaneously? Then we saw that there are two different ways you can do that. Either you can shift first or you can scale first. And as I was saying, shifting first is the easier operation. Why is that? Because then the scaling operation is simpler. So let's say you want to shift first. So in order to perform this operation, what do we do first? You just take the signal and then you shift first by some b amount. So you get a signal something like this, right? This is the shifted version. And then you scale. So in order to scale, what do? You squish. So the entire thing from here gets stretches. So you have shifted the origin, but in the new scale, the origin is here. So after the shift, you have to now squish or stretch about this y-axis. So if you squish or stretch about the y-axis, after you scale, what do you get? You get a signal something like this. Let's say it's squished. Because remember, you're going to squish about the y-axis. So you shift first and then you scale it. So this is the first operation, or this is the first way to perform this both shifting and scaling operation. So this is easier. So if you're doing the later, which you can still do, you can first scale, you can first squish the signal, right? squish the entire signal, and then you can shift it. But remember, you have already squished, meaning you have already scaled the time axis. So because you have already scaled, the shift of origin should also move in the scaled axis. So for this reason, you have to keep in mind that if you do the scaling first, the shifting now changes by a different amount, and that is by a scaled amount. So you move this in the scaled axis, whereas shifting does not affect the axis at all. So you just still scale it later about the origin, but whereas if you scale it first, then it affects the axis. So you have to shift by a different amount. There is another way which is very foolproof, I would say, and works for all kinds of transformations. The next technique, or another simpler way, is to note down these critical points. See what happens to the critical points T0, T1, T2, T3, and then you have to find out basically where this portion of the signal goes to when you scale and shift. So how do you find out? So you find out this point. So let's say this is T0, let's call this as some V0, let's call this as some V1, let's call this as some Vn. In this case, capital N is equal to 3. So let us say that for some value of A and B, this is V0, this is V1, this is V2, and this is V3. Okay. So at V0, which corresponds to T0, this is the starting point of the signal. So the signal ends up looking like this. Now, why is this true? It's because this signal essentially is nothing but what this is the time axis. This is x of at plus b. In other words, what we are saying is a v0 plus, so the value of time at this particular point t is equal to v0. So the value of the signal at that point is x of a v0 plus b, right? And we are saying that that is equal to, it is exactly the same point as the original signal at t0, right? So this is equal, this point is the same as this point. Okay, so we are trying to find out the value of this v0 where t0 gets mapped to. In other words, from this expression, we can say that a v0 plus b is equal to t0. So just manipulating this equation, we get v0 is t0 minus b by a, right? This is exactly what we have here. So this helps us to find the values of t0. In other words, this tells us to what point t0, t1, t2, t3 would get mapped on in the scaled and shifted version. Okay. So it can also so happen that if this a0 is negative, right, then you might get something like this. So you might have v3 to be here, v2 to be here, v1 to be here, and v0 to be here. So basically what you need to do is just find out the time instances of these critical points, find out where they get moved to or transformed to, plot those points, and then exactly plug in the magnitude or the amplitude of the signal in those locations. And then you get the manipulated or the transformed signal. Okay. So this is a quick summary of how to shift and scale in the time domain if you are given a signal. Okay. And this can be useful if you have an audio signal and then you are going to speed up, or you are going to change where the signal or the audio signal starts, or even if you have a circuit and then let's say you are going to you are given a signal, let's say you are saying that I am going to switch on the circuit at this particular time, and then you observe the output. But then if you want to know what happens to the signal if you had switched on later or earlier, and how would the output shift, in all those scenarios, essentially what you are doing is shifting in time or scaling in time. All those things you can observe or you can analyze by knowing these operations. Okay. Now, it can so happen sometimes that you will have to do the reverse of these operations, right? Let's say now you know how the signal looks like after it is sped up, but you want to find out the original signal, then you will have to do the reverse. So, how do you do the reverse operation? Keep in mind that we discussed last time that if you had shifted first and then scaled, the reverse operation should be the inverse, meaning you have to scale first and then shift. Okay. So, as you can see, the first operation here was shift and scale. So, scale was by A. In order to reverse that, you have to scale by 1 by A. That is what we have done here. And then the shift was by B. In order to reverse that, the shift should be by minus B. So, that is what you have done. And the next option is scale first, shift second. So, shifting was by B by A. So, you have to undo that first. Undoing that is by minus B by A, and then undo the scaling operation, and that is by scale 1 by A. That is exactly what we have done. So, given, let us say somebody gives you this signal and then asks for the original signal, then you have to do the reverse operation, and the reverse operations, keep in mind, have to follow this particular order. Now, what if somebody gives you two signals? Let us say I have been given this signal. Okay. And then I have been given something like this. So, let us say this is the input to the circuit and let us say this is the output to the circuit. Now, given this, I want to understand how this circuit has manipulated this signal. So, let us say this is an input to your recording device and then you see an output like this. Often you would see something like this in your video player, right? You would have a video and then the video would be at some order and then the audio would be some order. There might not be any synchronization between that. Means what? There has been a time shift. So, you have to do the time shifting operation. So, meaning you know that this has to be the signal, but then you are getting this. So, you need, in order to compensate for that, you need to know by what amount the synchronization has been lost or in what amount the shift has to be done. In other words, x of t is given to you and x of some a t plus b is given to you, but you do not know what are these values a and b. So, how would you find out these values a and b? Given these two signals, the first thing that you have to do is find 2 points, pick 2 critical points. Let us say in this case we have picked this point and these points. Okay, you can pick any 2 points, you can pick even the origin and another point. So, once you have picked 2 points, let us call those points T1 and T2 and then find out where they get mapped on into this manipulated signal. Let us say they get mapped onto these 2 points. Okay. Let us call those points T equal to V1 and T equal to V2. Okay. Now, we know that A times V1 plus B is equal to, or in other words, we actually know this, which means AV1 plus B is equal to T1. Similarly, AV2 plus B is equal to T2. We have picked 2 points which map on to the same value. So, which means those 2 points must be exactly equal. And from this, we have 2 unknowns. The unknowns are A and B. And then we have 2 equations. We have 2 linear equations in 2 unknowns. From this, we can solve and find out A. Okay, that is what we will do. So, if you just solve this, you will get A to be of this form, which is very simple. All you have to do is just subtract one from the other, and then if you just subtract this, then you will get A of V2 minus V1 is T2 minus T1, and then you just get A to be of this form. All you have to do is you have to ensure that you do not pick T1 and T2 such that this becomes and V2 and V1 such that this becomes 0. So, that you should not do. Okay. So, on all other scenarios, you will be able to find out what is A. So, once you find out what is A, what you have to do is now just then find out the value of B. So, you can solve this and find B. Another easier way is to substitute what happens at the origin. Now, let us say the origin 0 gets mapped onto a point, let us say V0 here. Okay. In other words, what we are saying is A times V naught plus B is equal to T naught or X. Okay, whatever is the signal's value at 0 might get mapped onto some other point at this manipulated signal. Okay, so we'll say that A V naught plus B is equal to 0. In other words, B is minus A V naught. We have already figured out what is A from this equation. So just know to which point the origin was shifted and then just multiply that by minus A and you will know what is B. Okay, so this is an easy way of figuring out what are the shift and scale parameters A and B. So now we understood and summarized how to shift a signal, how to scale a signal, how to do that simultaneously, and how to reverse these operations, and given the manipulated signal and the original signal, how to figure out the shift and scale parameters. Okay, these quantities or these techniques are now known to us. So you can go about and analyze any circuit now and then say that, okay, this circuit has shifted my signal by this much, this circuit has scaled my signal by this much in time. So this helps us in analyzing what the circuit does to our signal. Or if you want to devise a circuit, now let's say you want to devise a circuit which will perform the synchronization. Now let's say your video and audio are not matching. Then what you have to do is you have to now somehow create a technique to either delay your audio or to advance your audio. So which means you have to know by how much you have to shift, and then you have to come up with a circuit saying that, okay, the input of the circuit is x of t, but the output is now going to be x of t plus or minus b. So how to find out what should the value of b, this b should be, and how to change my circuit accordingly will all be accomplished by knowing these techniques. Okay.